Hello and welcome to section 7.2. This is our last section that we're going to cover in Calculus AP/AB. And so in this one we're talking about what happens when we revolve a solid piece around an axis, whether it be the x-axis, the y-axis, or any other axis. When you rotate rotate something around an axis, you'll end up with a solid piece. So if you have a curve and you rotate it around an axis, I would end up with, I have some curve that looks like this, and if I rotate it around the x-axis, I would end up with some kind of football shape thing. And so that's really what we're going to be doing. And so in this, we call this the disk method. And so what we're going to do to find the volume of the disk is, well, basically a disk is a cutout inside this piece. If we treat it like rectangles like we would for area under the curve, we have the rectangles. When you spin those around, they end up being a three-dimensional circle. And so we end up with, since we end up with a three-dimensional circle here, we end up with the area of the disk times the width of the disk, which is basically pi r squared times w. Well, this is how we're going to go about this. The width is how far up and down the x-axis we are moving. And so the formula that we knew before to find volume was basically pi r squared times w. And we're going to move it up a little bit and into integration. When we do that, our r squared is going to be from our equation, and our pi is still in the equation, and the dx becomes the width, because if we make those disks really, really thin, we're going to be able to find the small slices that are necessary, and just like before, using limits, we're going to end up with almost the exact area or exact volume of this curve. So the formulas that we need to know are these. If we are going to find the volume of a curve when we rotate it around the x-axis, it's going to be pi times the radius squared, which is the radius is part of the curve from the curve that we are given, and this yellow is just the little rectangle. And if we make that rectangle really, really thin, delta x really, really small, then we get nice thin slices, and they're shaped like a disk as they're spun around the x-axis. You could also spin it around the y-axis, and really the only thing that changes is that you're, instead of going from using the x-axis to for our upper and lower limits, we're using our y-axis, and we'll talk a little bit about that in class also. So make sure you get these down, pause it if you need to, because we need these for class. So here's our example. This is my example that I'm going to give you guys today, and we're going to find the volume of the solid that is formed by the equation the square root of sine of x. And we're going to go from 0 to pi, and it's going to be spun around the x-axis. So if I spin it, this would be what it looked like. It would really look like a football. And so following our formula from before that says from a to b, pi, to find volume, we are going to say pi times our radius squared times dx. So this will get us volume, because remember, radius squared times pi is the area of a circle, but since we're giving the circle some width, that's the dx here, the delta x, then that's where we're getting volume from. So using this, I could go ahead and plug in what I know. My volume will be equal to pi, and remember, pi is outside of the integration just because it's a constant, so we don't need to ever carry it inside. And so we're going to go from 0 to pi, because that's what they told me my parameters were up here. And I'm going to do the square root of sine of x squared dx. And so if that's the case, then I can go, well, I can do a little simplification. Squaring a square root will cancel out the square root. So my volume equation, and you can always do that, is try to simplify it as much as possible so that I am left with sine x dx. Now, the integration of sine shouldn't be very difficult. What did we differentiate to get to sine? Well, we differentiated cosine, but cosine would have gotten me negative sine. So the volume of this turns into pi times negative cosine x, and it's from 0 to pi. So plugging in my upper one, so now to find the actual volume, the volume is going to be pi. My upper value, putting in pi, is negative pi, which would be -1. I mean, pi makes this -1, so I end up with something that looks like this. And then I subtract away my lower, which is cosine, which, when I put in 0 for x on my unit circle, will give me positive 1, but I'm subtracting a negative 1. So I get something that looks like this, which really is saying that my volume is 2, or 1 plus 1, because all these negative signs. So the volume of this is 2 pi. Now we will come to class and do more of these, and we need to practice these guys. And there's a little bit different variations of these. So please come to class prepared to work on this, and we will talk more. And thank you for listening.